Today we're going to be doing our first steps into trigonometry. And trigonometry is probably one of the harder yet powerful things you're going to be learning here in geometry class. It's actually also one of the things that you'll probably take with you past this class. It may not be one of those, oh, I'm using it every day type things, but it's definitely going to be one of those things where it'll sit in the back of your brain, and at some point you're going to have to pull it out in your adult life. I promise you that. So without further ado, let's get into it a little bit. First, we have to go through a few definitions. With a right triangle here like this, we have a hypotenuse. You guys are familiar with the hypotenuse. That's the longest, not leg, the longest side of the triangle, and it's always opposite the 90-degree angle. That's not going to change. We'll still call that the hypotenuse. But before, we kind of had these two legs. We kind of had to say, oh, this is the longer leg, this is the shorter leg. Here, we want to define the legs with respect to a single angle. So in this case, we're going to angle A here, and one of the legs is adjacent angle A, and we'll probably refer to that as the adjacent quite a bit. The other leg is opposite angle A, so we're going to call that the leg opposite. Note here that adjacent and opposite are always with respect to a single angle, in this case angle A. If we were doing this with respect to angle B, we would call this leg BC here would be adjacent and AC would be opposite. So just keep that in mind as we move forward. The tangent has two parts. The tangent has two parts. The first is that it's a function. So when we are using the tangent as a function, it'll be tan, tan A. So for example, we could do the tangent of 30 degrees, we could do the tangent of 45 degrees, we can do the tangent of 16 degrees. That's a function there. We also have a definition here. The tangent of any angle is equal to the length of the leg opposite over the adjacent. So again, this is in respect to angle A. And I'll show you what I mean here in a second. I'm going to go over here. This is from GeoGebra. Somebody put this together. But we can adjust the sides here. Think of this angle as angle A. So this is the side adjacent angle A. Here's the length. It's about 5 units. Here's the length of the leg opposite angle A. It's also about 5 units. So what is the ratio between the opposite over adjacent? Well, what's 5 divided by 5? Well, that's 1. So the tangent of angle A here is 1. We can adjust this. As I start to bring this down, the value of the tangent of angle A should change, right? So if I click on this, I can bring this down. Let's bring it down to close to 2.5 and see what happens. So okay, I'm at 2. So now this is the tangent of angle A is equal to the opposite over adjacent. What's 2.5 divided by 5? Well, it's 1/2, right? I can bring this down further. Let's go down to 1.25 or so. 1.2, close enough. Again, the tangent of this angle, whatever that angle is equal to the opposite over the adjacent. 1.25 over 5, which comes out to 1/4. So that should kind of give you an idea of why we're doing this. It allows us to relate this angle with the values of the sides. Before, we've had no way of doing that, right? We had a few special cases of right triangles or things like that, but for the most part, we weren't able to do that. So we can just with this angle figure out what the relationship is between those sides. So we'll do some problems here. This one just asks, find the tangent of each specified angle, write each ratio as a fraction and as a decimal rounded to the nearest hundredth. So the first is angle A. The tangent of angle A, so the tangent of this angle over here, is equal to the opposite over adjacent. So it's going to be 18 over 24. 18 over 24 is the same thing as 3/4, or if you punch this into a calculator, you get 0.75. Right? Um, so for part B, we also want to find the tangent of angle B. The tangent of angle B is equal to the opposite, now, this is the opposite, right, over the adjacent. This is the new adjacent with respect to angle B. So opposite over adjacent. Opposite is 24, adjacent is 18. It reduces down to, and that comes out to 1.33. So real quick, notice here that the tangent of one of these angles on a right triangle is 3 over 4. The tangent of the other angle on this triangle is 4 over 3. So they're reciprocals of each other, right? One way to find the reciprocal is to just divide that value by 1. So go back here for a second. What is 1 divided by 0.7375? It's 1.33. And what is 1 divided by 1.33? It's 0.75. So you can switch back and forth between these simply by dividing 1 by it. Okay. So that answers that question. Why don't you go ahead and try and do 5 and 6 real quick, and we'll find a little pause thing. So figure it out. Pause. Okay. Enough of that. Angle Q, the tangent of angle Q is equal to the opposite over the adjacent. So 15 over 36. The tangent of angle R is equal to 36 over 15, or the reciprocal of the tangent of angle Q. So hope you got those. We'll do more practice later. Now we're going to focus on the function side of things. So if I were to calculate the tangent of a 15-degree angle, this would give me the ratio of the opposite and adjacent sides, right? So how am I going to figure these out? This is what calculators were invented for. You don't have to do all this funny math. So let me hop over here. I'm going to grab, this is a good one. So I'm going to clear this out. In your iPhone, if you were to calculate the tangent of something, you'd hit the number first, so you'd have like 0, and then you'd hit tangent, and it would just spit out the tangent of 0. Here, I have to punch it in the other way, or on some calculators, you have to punch in tangent first, and then hit 0. And this little parentheses means that it's going to take the tangent of whatever this angle is. One other thing to notice here is make sure you are in degrees. All scientific calculators have 2 options. They have radians and degrees. We haven't used radians yet. Radians are similar to degrees, but they're just another way to measure it. Kind of like Celsius and Fahrenheit, or inches and centimeters, or something like that. They measure the same thing, but they're different units. So it's going to get totally thrown off if you're on the wrong one here. If you get weird numbers ever, if you're having trouble getting these values, check to make sure you're in degrees. There should be a button on your calculator to switch it back and forth. So the tangent of 0 is, ta-da, 0. Okay, we're not going to go through all of these. See if you can plug each one of these into your calculator and try and get those. In fact, there's also, don't forget that there's one more down there at the bottom, tangent of 90 as well, if you can get that. So calculate all of those values, and I'll see you in a second. Pause. Okay. So notice here that when we start with the tangent of 0, we just get 0. That kind of makes sense, I guess. We have a nice narrow angle, so therefore our opposite over adjacent has a very small opposite divided by a large adjacent, right? So we get a small value here. But as we get up toward 45 degrees, remember this one here. Oops, not that one. Bear with me. This one. Remember this one here? As we get up toward 45 degrees, a nice 45-degree angle, we start approaching, what, a 1-to-1 ratio, right? So a 1-to-1 ratio, when you divide it, becomes 1.
5, 1.
So the tangent of 45 degrees is 1, and then we start getting into real big numbers. The tangent of 60 is 1.73, 75, and then what happens when tangent of 90?
732.
Whoa. Well, make sure you get this value. Make sure you write this down. See what type of big number that is. We'll talk about it later.
So
Okay,
that's
another example.
90.
Yep. Apply the tangent ratio to find unknown lengths. In order to meet safety guidelines, a roof contractor determines that she must place the base of her ladder 6 feet away from the house, making an angle 76 degrees with the ground. To the nearest tenth of a foot, how far above the ground is the eave of the roof? So here's the side of the house. Here's my ladder at an angle, right? It's at a 76 degrees and it's 6 feet away. So the question is, what is CB here, right? And we can set this up, we can set this up by saying that the tangent of angle A, right, is equal to the length of the leg opposite over the length adjacent. So tangent of angle A is opposite over adjacent. In this case, it's BC over BA. And we know 3 of these values, and once we know 3 values in some equation, right, or once we know all but 1 value in an equation, we can just solve for it, right? So in this case, we can say that the tangent of 76 degrees, this looks confusing and it looks complicated, and we think, oh, what is this? I don't know what this is. Just remember, this is a value. This is just some number, and your calculator will tell you what that number is. So Mr. Calculator knows this. Just think of it as a number. It might be unknown right now. We can figure it out later, but it's a number. Tangent of 76 degrees equals BC, which is our opposite, over 6, which is our adjacent. So to solve for BC, we need to get BC by itself. What do we have to do to both sides? Well, we multiply both sides by 6. Multiplying by 6 gives us BC equal to 6 times the tangent of 76 degrees. And then at this point, this is probably the best time to just punch it all into the calculator. Mr. Calculator spits out a value of 4.1 blah, 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 blah for the tangent of 76 degrees. Multiply that by 6, and we get approximately 24.1 for BC. All of our answers where you have to take the tangent function of something will be approximate, unless it's the tangent of 45 degrees or the tangent of 0, something like that, because they're just going to be these crazy long irrational values that go on forever. So it's one of those things we're going to have to live with. So we can say that BC is approximately 24.1 feet.
7, 8, 9.
All right, we'll try this one. For right triangle STU, what is the length of the leg adjacent, angle S? So here's angle S, the leg adjacent is SU. So we can set up our equation here the same way. We can say that the tangent of angle S is equal to the opposite over adjacent, right? The opposite value is 87. No, we're not there yet. The opposite here is TU. The adjacent is SU. So TU is 87. Measure of angle S is 54. We just plug those numbers in. So the tangent of 54 equals 87 over SU. Feel free to just skip ahead to this step when you're setting up the problems. You don't have to, write down this whole thing. I would just immediately go to this step and just say the tangent of 54 degrees equals 87 over SU. Or, you can put a little X in here, something like that. That's fine. Now we solve for SU. Since SU is on the bottom, we can't just divide by SU, right? We're already dividing by SU. So we're going to have to essentially multiply both sides by SU, and then divide both sides by the tangent of 54. Or you can put tangent of 54 over 1 and cross multiply. Let's see what the book does. Oh, they just do it all in one step. So they assume you can algebra that one. SU, therefore, is equal to 87 divided by the tangent of 54. Mr. Calculator knows what the tangent of 54 is. So you ask Mr. Calculator, and he says this thing. And then you can take 87 divided by that thing, and we get some value. So our unknown length here is 63 point. What is that, Willie?
2.
63.2. Yep. Okay. Your turn. Go ahead and see if you can do number 7. We'll pause it here for a second with something. I don't know what yet. Pause. Okay, and you're back. So if we were to set up a picture for this, we can set up a picture real quick. It says a ladder needs to reach the second story window, which is 10 feet above the ground. So here's my picture. Okay, I know that that window is 10 feet above the ground. It's going to make an angle with the ground of 70 degrees. So this one here is going to be 70 degrees. How far out from the building does the base of the ladder need to be positioned? This one's 90 degrees, by the way. So they want to know what x is, right? And I could say, well, the tangent of x, or the tangent of 70 degrees is equal to the opposite over the adjacent, right? So tangent of 70 degrees equals opposite over adjacent. Solve for x, and then plug it into a calculator. That's all you got to do. We're going to pause here. The rest of the lesson is going to be on another video. So thanks.